So path means this is the directory where this file is stored. Okay, diabetes.csv is stored in a directory or in raw files. And after reading the diabetes.csv, it is stored in diabetes. So what will be the class of, actually this diabetes is a data frame. It is the class diabetes will determine the internal class of the object database. So this is the output. So this hash represents the command prompt. So just ignore this portion. So output of class diabetes is data frame. That means this diabetes is a data frame. So next we study another function known as type of. Type of will determine the storage type of the object. Here the object is diabetes. So we are determining the storage type of the diabetes. Actually, diabetes is a data frame. So this one is the output of this command. So just ignoring this portion, it returns list. That means diabetes is stored as a list. What is diabetes? Diabetes is a data frame. So data frame is stored as a list. So for a class will determine the internal class of the object and type of will determine the internal storage of the object. So data frame is stored as a list, but the class of data frame will return data frame. So next we will discuss another function, head. So head or head syntax is like this: head within bracket object. Here the object is diabetes. Diabetes is a data frame. So actually it is a standard database. So it will return first lines of the database. So here as we seen 6 lines of the database is printed. So these are the headings of the database. This subject, this one is the heading of the database. Let's discuss some other functions. Column names of diabetes. Syntax is column name of object. So it will return the heading of the database. Previously we had seen that the headings are subject. These are the headings. So after this sixth 1, 2, 3, 4, 5, 6, height is the sixth attribute and weight is the seventh attribute. That's why it is written like this 7. Weight 3. So totally 1, 2, 3, 4, 5, 6, 7, 8 columns are there and the names are written here. So n column of diabetes will return the number of columns of the diabetes. So here 8 columns. So it will return 8. 8 is the output. Then next function is n row of diabetes. Actually this database will contain 354 entries. So this command will return 354. Just ignore this portion. Output is 354. Okay, let's create another data frame with 2 columns. First column consists of numeric vector and the second column consists of string vector, character vector. Not string vector, it is character vector only. So first we are creating a numeric vector and then it is followed by this one is a character vector. So we had seen previously that to create a vector, we need to use concatenation function. So FOO is the column name of that vector. Name of the vector is FOO. and it is the first column. So first column consists of numeric vector, and in the second column we are storing the characters. So vector name of this column is bar. That means in the data frame the column name will be bar. And we are using concatenation function to store the vector values. Here values are characters. So what will be the output? So ignoring this portion. Ignore this portion. So this is the output. First column consists of the name of the vector is FOO and the elements are 10, 20 and 30. And the second column name is bar and the elements are A, B, C. How to access the rows and columns of the data frame? So we can access data frame using this syntax. Here df is the data frame and value 1 refers to the rows and value 2 refers to the columns. The row or column can be a number or string. Value 1 or value 2 can be an array of values like 1 colon 2 or C of 1 comma 3. We can also specify the column names alone. That is df of value 2. Remember that there is no need of comma here. This command will refer to the column alone. Let's consider the previous example. Here we are using three vectors. First one is a numeric vector. This one is a numeric vector, and then it is followed by two character vectors. Vector 1 and vector 2. Vector 2 is a character vector with elements R, Scilab, Java, and vector 3 is another character vector with elements 4 prototyping, 4 Scilab. So we are creating a data frame using these three vectors. So consider this example. Okay, to access the rows and columns of the data frame, the syntax is like this. df of within square bracket you have to specify the row and column. Remember that you have to specify row and column within square bracket, not ordinary bracket. So this df refers to the name of the data frame. So first argument refers to row and the second argument refers to column. So for example, to access the first and second row means this portion. How will I specify the first and second row? First and second row means 1:2. And you have to specify the column. But here they need all the columns, means no need to specify the columns. You just write 1 to 2 comma, that is print df 1 to 2 comma. So this one is the screenshot. So output will be like this. First one, this one is the column. It is we are just printing the first and second row and all the columns of first and second row. Now suppose you want to access the first and second column alone. Here we are not specifying the row. We are not specifying the row means we need to access all the rows. All the rows means you just put a comma here. This is the row. And it is mentioned that you need to access the first and second column. So first and second column is rotated like this, 1, 2. So let's check the output. This is the first column and this one is the second column. Note that the vector 3 is absent here. Also, all the 3 rows are printed here. An alternate way of accessing first and second column is like this. Here there is no specification of row. That means we need all the elements present in the row. We need all the 3 rows. So we just need to specify the columns. Then within square bracket you can ignore the first argument. So one argument is sufficient for this command. So here we need, so row is absent and we need first and second column. So first column, then second. This is the notation. So you will get the same output as previous. Next command is subset function. Subset function will extract subset of data based on some condition. This condition is very important. So create a new data frame with name, month, blood sugar and blood pressure as columns. So 1, 2, 3, 4 columns. Extract a subset with the name as Sendil or the blood sugar level value greater than 130. Okay, let's create a new data frame, namely PD. So here we are assuming 4 attributes: name, month, blood sugar and PP. So in order to create that attribute name, we need a character vector like this. So with elements Sendil, Sendil, Sam, Sam. And the next one is month attribute. Again, we need a character array, character vector with elements Jan, Feb, Jan, Feb. And next one is blood sugar. It is a numeric vector with elements 140.4, 120.3, 110.4, 120.6. And BP is 90, 70, 23, 70. It is again another numeric vector. So this code is to create the data frame PD. So now our aim is to extract a subset with name as Senthil and blood sugar is greater than 130. For that you can use a command like this. PD subset. Database name is PD. Database data frame. PD, comma, name equal to Senthil or blood sugar greater than 120. This is the condition. So what is the syntax of the subset function? First you have to specify the data frame, comma, you have to specify the condition. Okay, after that print the subset PD2. Can you tell the output of this code? So actually we need to extract the name as Senthil and blood sugar greater than 130. How many names are there with name Senthil? 2 names. Senthil, Senthil. 2 names with Senthil. So blood sugar greater than 130. How many values are there? It is greater than 130. Only one value. This value is greater than 130. All other values are less than 130. So what will be the output? Actually condition is Senthil or. Or means either this condition or either name equal to Senthil or blood sugar greater than 130. So how many Senthil will be printed? 2 Senthils. Okay, this one is the screenshot of the code. So what will be the output? This is the output. So print new subset PD2 means you will get an output like this. 1 new subset PD2 means whatever be the character within double quotes will be printed. So next line is print PD2. This is another output. Print PD2. Output of print PD2. What is PD2? It is a subset. So previously we had discussed that we will get two single names. Okay, how to edit data frames? Data frames can be edited by direct assignment. So consider the previous example. Here we are using three vectors. First one is a numeric vector and second vector is a character vector and two character followed by another character vector, vector 3. So it is concatenated and a data frame is created. So how to change the second component of the second vector? Actually, the second component of second vector is, what is the second component of second vector? That is Scilab. So second component of second vector attribute is represented within two square brackets and the value is represented using a single square bracket. Attribute is represented using two square brackets and value is denoted using single square bracket. So df 2 equal to r. Let us check the output of this one. So what is the value of the second attribute and what is the value of second attribute? It is r. It is changed. Previously it was Scilab. Now it is changed as r. Another way of editing a data frame is to use a edit command. Okay, create an instance of data frame and use edit command to open a table editor. So use my table equal to data frame, then issue a command edit my table. Actually, we are trying to create a table manually. After issuing these two commands, a pop-up window will open as follows. Okay, a pop-up window will be like this. So you can edit the data frame manually. You can add the values to each and every cells present here. After typing all the data, you can quit the pop-up window by pressing quit button which is located on the top of the window. This is the screenshot of edit table. You are creating a data frame using the name my table and the data frame is empty. That means you can actually enter the values manually. Okay, I am adding two column names, Maths and English. So after adding the column name, values are entered here. So 2, 23, 45, 12, 47, 73, and 50 are the values. These are the max mark and these are the English mark. Also, you can copy these values, you can paste it, and after editing all the data in the data frame, you can quit it. Actually, infinite number of values can be entered here. This data frame is stored in variable my table. So once you issue print my table, it will give the data frame. So we are having two columns, Maths and English. These are the These numbers represents the row numbers. So first row max is 23, English is 47. How to add extra rows and columns? To add extra rows and columns, you can use two functions, rbind function and cbind function. To add extra rows, you can use rbind function, and in order to add extra columns, you can use cbind function. So consider the previous data frame with three vectors. First vector is having numeric value and the second and third vector contain character values. So we are binding one more row to this data frame. So if to adding extra rows, we can use rbind function. Syntax of rbind is rbind is. First, you have to specify the name of data frame, and comma, data.frame, then it is followed by data, create a new data frame. Here we are having three vectors. What are the vectors? Vector 1 contain a numeric value. So vector 1 equal to 4. So data frame contains three vectors, vector 1 equal to 4 and vector 2 equal to C and vector 3 equal to 4 scalar. After adding this database, this row, we are printing it. Then to illustrate the cbind function, we are adding an extra vector, extra column vector. Actually, it is a numeric vector to this data frame df, and after that print the data frame. Syntax is cbind followed by entries. To add extra rows, use rbind function, and to add extra columns, use cbind. Okay, this one is a screenshot. To add extra row, we are adding three vectors. v1 equal to 4. This fourth element of vector 1 is 4. And fourth element of vector 2 is C. And fourth element of vector 3 is scalar. Vector 1 is 4. Vector 2 is C. And vector 3 is 4 scalar. This one is the row we had added. This row is added here. Okay. Then after that, we are using cbind function. Cbind. So in order to add the cbind function, we need a single vector, vector 4, with values 10, 20, 30 and 40. So it is printed here. Vector 1 with values and vector 1 with values 1, 2, 3, 4, same as here. And vector 2 with values R, Java, C, same as above. And vector 3 with values same as, and it is appended with another vector, vector 4 with values 10, 20, 30, 40. Okay, how to delete rows and columns? You just put a negative sign before the row to delete. So for example, delete third row and first column. So syntax is df followed by first attribute is row, then it is followed by column. So here we want to delete the third row. Delete means you have to add in minus and row is 3. So minus 3 and followed by comma first column. We need to delete first column. So minus 1. So df2 equal to df minus 3 minus 1 print df2. So this one is a screenshot. From this we can see that the third row, 1, 2, 4, third row is deleted already and first column is deleted. We can see the vector 2, vector 3 and vector 4. Vector 1 is deleted. Another way of deletion is conditional deletion. In order to specify the conditional deletion, you have to add exclamation mark before the number of row or column which satisfy the condition. For example, to delete third column means the name of third column is vector C, vector 3. So in order to delete vector 3, we are using the name of the data frame in vector C. So after deleting it, it is to be noted that exclamation mark is used here. So after that, print df3. So check the screenshot. We want to delete the vector 3. So after this, vector 1 is there, vector 1 is there, vector 2 is there, vector 3 is absent. After that, you can see the vector 4. Okay, this code shows all the details of the data frame with vector 1 which is not equal to 3. How will you represent vector 1? In order to access the individual vector, first you have to specify the data frame name. Followed by you have to write a not hash symbol, it is dollar symbol. Followed by you have to write a dollar symbol. After that you have to write the name of the vector. We need vector 1. So it is followed by vector 1. Vector 1 not equal to 3. Not df dollar vector 1 equal to 3 is stored in df4. Then print df4. Check the output. Here vector value 3 is absent. Only vector 1, 2, 4 is printed. All the other details related to 1, 2, 4 are printed here. Manipulating rows. When character columns are created in a data frame, they become frames. Factor variables are those where the character column is split into categories or factor levels. The following example shows other categorical variables which are not available and it is replaced as NA. For example, df 3, 1. 3, 1 means the third attribute and first column. So it is 3.5. And third attribute, third element is assigned as others. Let's check the screenshot. So df31 is assigned as 3.1 and df33 is assigned as others. So after that, you will get a warning message like this. Invalid factor level. Why it is invalid factor level? So what is the meaning of df31? 3 represents the row and 1 represents the column. That means in the first column, third element is modified as 3.1. In the first column means vector 1 third element. Vector 1 third element is modified as 3.1. And in the second line denotes df33 means vector 3 third element. It is assigned as others. It is assigned as others, but it is printed as NA. How to resolve the factor issues? So new entries need to be consistent with the factor levels which are fixed when the data frame is first created. To eliminate the error set, string as factor equal to false. So considering the same example, vector 1 is having elements 1, 2, 3 and vector 2 is having elements R, Scilab, Java and vector 3 is having elements 4 prototype, 4 Scalab. And after that, data frame is created with 3 vectors, vector 1, vector 2, vector 3 and it is followed by string as factors equal to F. So this will eliminate the error due to factor levels. Now consider adding others. This one is a screenshot. We are adding string as factor equal to false here. So we got the data frame like this. Now try the same manipulation. That is df33 equal to others. So what will be the output? Previously we got a n value here. Now we got others because we set string as factor equal to false. Recasting and joining of data frames. Recasting is the process of manipulating a data frame in terms of its variable. It helps in reshaping the data, which bring more insights on the data when it is seen from different perspectives. Consider the previous database with 4 attributes: name, month, blood sugar and BP, and it is printed here. We are considering the same data frame once more. In order to recast, we use 2 commands, melt and cast. These commands are a little bit complicated. So there are different types of variable. One is identifier variable. Identifier variable means it is discrete type of variable. And another type of variable is measurement or numeric variable. Measurement variable means it will be numeric only. Categorical and date variables are not measurement variables. Date variable means suppose 21/9/2020. It is not a numeric variable. There is one hyphen or slash is there in the variable. So it is not a measurement variable. From the data frame, you have to identify the variable as well as the measurement variable. In order to use this recast, we need a new library, reshape2. You have to install this reshape2. In the previous class, we had discussed how to install a new package from the packages panel. Where it is located? Packages panel is located in the bottom left portion of the RStudio. So this one is the syntax of melt command. Melt, then it is followed by within bracket. First you have to mention the data id.var, that is identifier variable, followed by measure variable, comma, variable dot name equal to variable, value dot name equal to value. Arguments are data frame, ID variable, measurement variable and default values.